Let's look at subtraction of large numbers. Now, we've looked at an example of addition of large numbers before. We want to look at one or two examples of subtraction here. Now, suppose you have, for example, I want a different color. 1005 minus 7. Now you see that the top number here is smaller than the bottom number. If it was 7 up here and 5 down here, you would just say 7 minus 5 is 2 and then you carry on. But that's not the case for us now. The 5 is smaller than the 7. Now you probably are already familiar with a method to use and subtract these numbers. But we want to look at one common method used and then study it to see why it works, because we don't want to just do something and trust that it works. We want to understand it. Here you would say 5 minus 7, you can't. Then you try to, the first time I learned this thing is to try and borrow 1 from the 0. You can't. Borrow 1 from this 0, you can. You borrow 1 from this 1, cross it out, it becomes 0. As you proceed back to the right, this 0 becomes 9, this 0 becomes 9, and this 1 becomes 15. Then you say 15 minus 7 is what? 8. It's 8, and you write the 8 down here. And you say 9 minus 0 is 9. 9 minus 0 is 9. And that's what you have. Alright? Now let us scrutinize this thing to see if it really is something that we can trust in all cases. What we have, all right, let me put in the columns. Here you have ones, tens, hundreds, thousands. These are columns. Anything you see in this column represents 1, 10, hundreds, thousand. Now 1005, it means 1000 plus 5 ones, and then the 7 is just 7 ones, right? Alright, now if you consider this 5 ones minus 7 ones, you can't do that, right? But what you can do is take the 1000 and split it in 2 parts. Let me move the 5 a bit down to make some space. Let's put the 5. Alright, let's keep the 5 in black. Let's put the 5 down here. 1000. If you consider 10, you split 1000 into 10 parts. How many is left? How many parts are left? Is 990. Because you know that when you have 1000 and you take 10 away from it, you have 990 left behind. Right? So let's cross out this 1000 up here. We're not going to use it again. Here what you say is there is 5 ones minus 7 ones, but the 110, it means the same as 10 ones. So let's bunch up everything right here. Now you notice that this 15 that you said you subtracted 7 from, This 10 ones plus the 5 ones, it's 15 ones. You see it over here? This is 15 1 minus 7 1. So this is 15 ones minus 7 1, because this is 10 ones plus 5 ones give you 15 ones, right? And all of this is the 15 ones minus 7 ones. You know, 15 minus 7, 15 of something minus 7 of it is 8 of it left behind. Alright, we've used up this 10 and this 5 and 7 already. So we concentrate on the 9 now. 9 minus 0 is just 9. 9 minus 0 is just 9. We've already said that we're not going to be using this 1000 here. We've already rewrote it as 910 plus 9 as 900 plus 90. All right. So what you have here is 998, just as we got over here. But the quick mechanical way of doing it is to say 5 minus 7 you can't, borrow 1 from this 0 you can't, borrow 1 from this 0 you can't, borrow 1 from 1 you get 0, going back across you get 9, 9 and 15. But it's important to understand how it really works and why it works. Alright, so that will be it for now. We'll have another video later on.